Well, welcome, Algebra 2. Hope your test went well. Good luck on that extra credit. Chapter 6, Section 1, we'll be looking at graphing exponential growth and decay functions, and then using exponential models to solve real-life problems. The first thing that you guys are going to look at today is a little Desmos activity called Avi and Benita's Repair Shop. I'm going to go through the first couple screens with you so that way you're on the right track. And then if you want to work with a partner, be sure, of course, you put both of your names in always. Avi and Benita run a repair shop. They need some help, so they hire you. Good choice. They have different options on how much they'll pay you each day, and you'll learn about those rules in a moment. Just realize this, each day you get to choose whose rules you prefer. So one day you could be paid under Avi's rules, the next day you could say, I'm gonna go to Benita's rules. You could switch back again. Or you could just say, I'm gonna stick with Benita. It's totally up to you. Complete the table. The table shows how much you'll earn with each rule. Complete the table for day 4. You'll actually type your answer in here and here, and then you'll predict who do you think will pay more on day 10. So let's start with day 1, Benita. Benita pays you $100. Day 2, she pays you $200. Day 3, $300. How much would day 4 be? If you said 400, you would be correct. Now, a little trickier. Let's go over to Avi. Avi starts off day 1. They give you one shiny penny. That's it. Wow. Can you imagine? You work all day, you come home, and you say, hey, how was work? Oh, great, I made a penny. And that probably would not go over too well. The next day you come home. Wow, I made 2 cents. Oh, wow. Twice as much. That's amazing for working all day. I think I'm going to go with Benita on day 1. I think I'm going to go with Benita on day 2 and day 3. Day 3, I get 4 cents under Avi. I went 1, 2, 4. What would be next? There is a pattern, and it does not involve addition. So, how do you go from 1 cent to 2 cents to 4 cents? You double. How do you double? You multiply by 2. So 4 cents, if you double it times 2, you'd have 8 whole cents. So day 4, I'm sticking with Benita. Who do you think's going to pay more on day 10? I'll let you decide that. Be sure you submit your table. That way it will let you know if you got the table right or not. And those values are going to carry over onto the next screen as you extend the table and enter the values for days 5 to 10. So you'll be able to see, were you correct in thinking that Avi or Benita, whoever you chose, was going to pay more on day 10. So that's your Desmos activity you'll start with. Should take you about 15 minutes tops. Work with a partner, you'll get farther. Pause your notes, come on back when you're ready. Today, Chapter 6, Section 1, we'll start off looking at exponential growth. There would have been an activity, but we're not here for it. So we're just going to pretend that we already did the activity and move on. It would have been the zombie apocalypse. Oh no! The Walking Dead, they're coming for us. What would have happened was day 0, we'd have our initial person infected. Day 0 is like where it begins. It's patient number 0. It's the first person that gets infected. And then that person would have infected someone else the next day, so it would be up to 2 people that are infected. And each of those 2 people would have picked another victim for the next day, so we would have doubled and had 4 people infected. And those 4 people would have chosen a new victim. Oh, brains. We double again. We'd be up to 8 people. Those zombies need some new brains, so they'd go out and find 8 victims. On day 4, we'd be up to 16 people. And then we would double again for day 5. The entire room would have been infected and then some. If you keep doubling, you'll find it won't take long till you reach the entire building, the entire city of Akron, state of Ohio, country, world. If you keep doubling, it grows very quickly. In fact, it grows exponentially. If you need graph paper, I always keep graph paper over there by your calculators. Let's take a look at plotting the points that fit. Not everything's going to fit. 0, 1. So here's our y-intercept. That's patient 0. It's where we began. We had one person, it had to start somewhere. Day 1, we were up to 2 people. Ooh, it's linear. No, it's not. Don't draw a line. Day 2, it goes up to 4. You can see it's no longer linear. Day 3, we're up to 8. You can see it's starting to curve. Day 4, we're up to 16. And day 5 is off the charts. It's not even going to fit. But I can see that I get this curve here. Whoa, missed it by that much. Let me try again. I get this exponential curve. There we go. Much better, Mr. Brown. That keeps growing and growing and growing by doubling. So what is exponential growth versus exponential decay? Well, growth means things are going up, like population growth. You have a lot of births versus population decay. Population is declining. Money, compound interest, if you invest it, can grow exponentially. Well, so can your bank account if you are spending money on a loan. It could decay. When you buy something expensive like a car or a television, electronics, the value goes down over time. So value of a car starts off here. When you buy it, it drops very quickly as it gets older and older and starts to rust and the wheels fall off. It's called depreciation. Value's going down. Bacteria grows exponentially. You start with a few, it doesn't take long till there's millions and millions of bacteria. You might have seen in science class a little talk about radioactive decay. Those are called half-lives. So you start with something and then next thing you know, you have half as much. Well, not the next thing you know. It usually takes hundreds or even thousands of years for that stuff to decay. So for instance, if we have a half-life of 5,730 years for carbon-14, those atoms, you start off at 100 atoms. After 5,730 years, now you have half as much. Another 5,000 years goes by, you have half as much. Another 5,000 years, half as much. And it keeps decreasing like that. Half, until there's so little left that we can't even tell. But you're talking probably hundreds of thousands, if not millions of years at that point. Hey, why was there no brain break today? Because zombies eat brains, duh. Left brains. Those are mathematician zombies. Because you use the left side of your brain. Get it? Artistic people use the right side more. So where does all this lead? Well, we're going to be graphing and learning about exponential functions. So let's take a look at our parent exponential function. Go ahead and jot it down in your notes. F of x equals b to the x power. Where's the x? Oh yeah, it's up in the exponent. So that makes this b the base. And then our x is up in the exponent. The x is where we start plugging in numbers from a table. -2, -1, 0, 1, 2, that kind of thing. How do we know if we have growth or decay? Well, when b, our base, is bigger than 1, so 2, 3, 4, even 1.1, 1.5, those are bigger than 1, you will have growth. And your graph will grow. Like that. So when do you think we're going to have decay? Not bigger than 1, but less than 1. And in fact, between 0 and 1. So 0.5, 0.1, 0.25, anything 0 point, which means your fractions also. 0.5 is a half. 0.25 is 1/4. So any fraction or decimal between 0 and 1 is decay, and our graph will go down instead of going up. You always start walking your graph on the left-hand side. We're decreasing, 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 decreasing. We are starting on the left-hand side. We're increasing, 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 increasing. This here, y equals 2 to the x. What do you think? Growth or decay? It would be growth because our base is 2. And in fact, that's the model that we used for that zombie apocalypse. 2 to each of those powers. 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth. This was our y equals 2 to the x. We plug each of these numbers into our exponent on our calculator. You get the answers for the number of people that are infected. How about this one? Y equals 1/2 to the x. Well, 1/2 is 0.5. It's between 0 and 1. So this would be our exponential decay. Our graph is going to be going down. That's what it would look like. Okay? We'll get into those more as we progress. Have a great Viking day. Bye.